So step one, I already know it's to let them react, so I'm just going to show it here. I'm going to quit writing that, let acid and base react. And I'm just going to show you that's what I'm doing by writing the chemical equation. I really don't care about water. This is my ICF table. Remember, we're working in moles. This is stoichiometry. So we know we started with 25 millimoles. This is millimoles. Just tell the grader. If you're working in moles, put MOL, but if you're working in millimoles, put MMOL. We're adding 25 of the base. So I already see that they're going to neutralize each other. We don't have any of that to start with. So minus 25, minus 25, plus 25. So we just made the salt. We don't have any excess weak acid. We don't have any excess base. We just have the salt and water. And so what's in my beaker at this point is I'm going to put Na plus just so you can see it's the salt and water. Who cares about water? We don't need to draw water. Water's the squiggle. We only draw the water molecule if they tell us to do that. But it definitely does not have a buffer anymore. It is not a buffer. A buffer must have the conjugate acid, the weak acid and its conjugate base, or the weak base and its conjugate acid. Has to have the conjugate acid base pair. Can't have part of the pair. So this is not a buffer. So I'll write that, not a buffer. So I cannot use my weak acid equilibrium because I don't have any of that. All right. So step two, we still need to get the concentrations of everything left over. So the concentration of A minus is going to be 25 over, and we took 25 plus 25 milliliters of the acid and base, so 50. And that is half molar. Okay. And I don't need the concentration of anything else. Water, sodium suspectator, water is a pure liquid. So step three. All right, step three. I cannot use that. I don't have any of that. So the only thing I have in my beaker is the conjugate base, and it's going to react with water. And it's going to form acid donates to the base. It's going to form some weak acid, not much, but a little, plus the hydroxide. So this time, this is the big deal. At the equivalence point, it is going to be basic, not acidic. And that's because you had a conjugate base left over. The conjugate base was what was left in water. So of course, a base in water is going to be basic. All right. So this is how to generate, and this is not a chemical reaction. I messed up. That's an equilibrium. This is an equilibrium. It's still equilibrium. You just have to write it yourself. So like you learned yesterday in the note packet, weak bases can be either amines like NH3, NH2, CH3, methylamine, or they can be conjugate bases of weak acids. Those will react with water. And so that's the case we have today. So we're going to set our rice table. Okay. Initially, what do we have? 0.5. It's water. Who cares, right? Just mark out the water. You don't have any of this initially. Minus X reacts, form X, form X. You get 0.50 minus X, X, and X. So this is a little bit different, okay? So this is not a common ion anymore. Now, you need K for A minus. Kb for A minus is equal to Kw, this is what you learned yesterday, over Ka. Now what's the conjugate of A minus? HA. So it's this number you're going to go look up in the table. We already know what it is. If we're looking with acetic acid, this is acetic acid, that's acetate. And so that's just going to be 10 to the minus 14 over 1.8 times 10 to the minus 5. And so Kb, so K for A minus, we'll just say B. No, well, we'll say A minus. That's not acid, that's A minus. Is going to be 5.56 times 10 to the negative 10, I believe. All right. Now you're able to go and get not the hydronium, but the hydroxide. You're going to be able to get the hydroxide now. So we have hydroxide ion concentration. And I think you should write your Kb out. Because this is a different type of equation, I think you should write the Kb as the expression. And then you can put 5.56, or we better do 5.6 times 10 to the minus 10 equals, and this time we have an x squared, right? Over 0.50 minus x. But look at that Kb. Kb is so small, and they're way more different than 5 orders of magnitude. So I'm not going to have to worry that x is going to change when I subtract it. I'm still going to be at 0.50. So we get x equals, this time, check it, hydroxide. And that's going to be the square root then of the Ka. And that should look familiar to you. The square root of the Ka times the initial concentration. And so hydroxide equals square root of 5.6 times 10. Here's our little EE button, times 10 to the negative 10. And then we're going to multiply that by half. Close my parentheses. And okay, no real calculation. All right. Oh, I said 5 times 6. Let me try that again. That's not, there's something wrong with what we did. That's something wrong with Dr. Legrone inputting into a calculator. So the square root of 5.6 e negative 10 times 0.5, close my parentheses. Yes, I'm happy. 1.7 times 10 to the negative 1, 2, 3, 4, 5, I think. And that's a concentration. Now I'm just going to get the negative log of that. 4.78. So that's the pOH. You are not done to get the pH. So I'm out of sync. I'm going to have to do it up here. So taking it up there, I hate doing arrows. pH is 14 minus that. 14 minus my answer is 9.22. And that is how you do it when you're at the equivalence point of a titration. When you're at the equivalence point, you are not going to have any acid or base. You are only going to have the salt and water. And so you have to let the conjugate base of the weak acid react with water. And set up your rice table just like we did before. You're not going to have a common ion. These are going to be 0 again. and you're going to always get to neglect. So these K's, because they are inversely related, these the KB of the conjugate base is going to be very small. You can always neglect that x. So the calculation again, instead of just being the square root of the KB times the initial concentration of the conjugate base. So simple math there. You just got to remember not to call that the H plus. That's where most students miss it. They'll get all this right, and then they'll say X equals H plus, and they'll get it, and they'll tell me the pH is 4.78. Incorrect. Always go back to your rice table. How did you define X? You defined X as hydroxide. So this has to be the hydroxide. And then you get the POH and subtract from 14 to get the pH.